Hey, eighth graders, welcome back to the second lesson in our new unit on statistics. Well, yesterday we talked about what a scatter plot is, and we talked about what correlations are and how to describe a correlation. Today, we're going to walk through the steps of actually creating our own scatter plot by hand. So make sure if you have not yet gotten any graph paper or printed out graph paper that you take a second to do that before you continue with the video. You're going to need it for today's notes. Okay. So as you can see, our aim today is going to be to create, and we'll analyze a scatter plot. Just by analyzing, I mean sort of describing what the correlation is and maybe even making a prediction. Who knows? Okay, so let's skip right into the do now that I created for today. For each of these scenarios, what I want you to do is just describe whether you think it would be positive, negative, or no association, and then sort of explain why. I'm just going to walk through it with you. If you want to hit pause and try it on your own and then see if our ideas or our solutions match, feel free to do that. Okay, the amount of free time you have and the number of classes you take. Well, if I think about that, if I take more classes, so if that were to go up, the amount of free time I'm going to have is probably going to go down. So if the variables behave oppositely, that's a negative correlation. As one goes up, the other goes down. That's a negative correlation. Okay, number two, the sales of snow shovels and the amount of snowfall. So let's think about this. As the amount of snowfall goes up, we can probably expect that the sales of snow shovels will go up as well. So since they both behave the same way, we're going to call that a positive correlation because the variables behaved the same. You could say as the amount of snowfall goes down, so with the sales of snow shovels, like this year, I bet you they didn't sell a lot of snow shovels. Still, that would be considered a positive correlation because the variables behave the same. All right, third one, length of a baby at birth and the month in which the baby was born. So we say length of the baby, like how big the baby is. And, if I think about that enough, there's probably nothing about the month the baby is born in. Like a baby born in December, it isn't necessarily bigger than a baby born in June. So I'm going to probably say this one has no correlation. I mean, why would it matter what month you're born in and how big the baby is? There's other factors that determine the length of a baby, but not the month that it's born in. Okay, so there you have it. If you need to, pause the video, jot any notes down. If you have a question, jot that, and make sure you meet me in the meet to ask that question. Okay, moving on from the do now. All right, so today we're going to be creating a scatter plot. A couple things I want you to keep in mind as we create our scatter plots today. First is we're going to create some axes, and we're going to label our axes. Really important that we do that so we know which variable is being shown on each one. After we've created our axes and we've labeled them, then we're going to need to choose an appropriate scale. And this is probably going to be the hardest part of today's lesson, determining what would be an appropriate scale for the numbers that we have. Now, after we've chosen an appropriate scale, if we need to put a break in our graph, we'll do that. That's something you've probably done in science. If you've never heard of that, we'll talk about that today. And then once we have our scale, our axes set up, we'll go ahead and we'll plot our data as coordinates. And then at the end, if we have some time, we'll make some sort of prediction. Okay, so what you see here is the data that we're going to create our scatter plot with. Table below shows the weight of a car and the fuel efficiency. So here's 13 cars that have an automatic transmission, and they were all 2009 cars that were made by Chevy. So what we've done here is we at least made them all from the same company and the same sort of engine, automatic transmission. So it's a good way to sort of compare. And just by the way the table is set up, I'm going to put weight on the x-axis and fuel efficiency on the y-axis. Now, to be honest with you, it really wouldn't matter if we switch those around. But to be consistent, so all of our graphs look the same, let's put weight on the x and fuel efficiency on the y. Okay, I'm now going to go to my next screen, which has graph paper. Why don't you get out your graph paper as well? Oops, need to go back up a page. Here we are. Okay, so I put my data up in the corner there so I can at least see what I'm working with. I'm going to write on this screen. I'm going to erase some stuff. So also leave some notes, some place for you to write some notes too. Number one, we knew that I think the notes that I gave before said we want to set up our axes and then we want to label it. So I'm going to just draw a line and set up my axes. Here's my Y. Here's my X. And my X, that's going to be weight. And on my Y, that's going to be fuel efficiency. Now, if you're saying, what is fuel efficiency? It's how many miles per gallon a car gets. So how many miles can that car go on 1 gallon of gas? The more miles you can go, the more fuel efficient we say. Okay. Now mine's a little sloppy again because I'm using a stylus on a computer screen. Yours should look a lot better than this. Now we have to determine what scale we're going to use. So if I look at my weights here, look for the smallest amount, which looks like 2,550, and look for the highest amount you have to go. Looks like 5,600, I think. So if that's the case, I don't really need to start at 0 because the first car that I'd be plotting doesn't happen to come up until I get to like 2,550 pounds. So the better idea would be to put a break on our axes. What that means is we put a mark like this, and I'm going to draw it in. And now we can start our scale, not at 0, but anywhere we want. So maybe we'll start it at like 2,000 or something. Okay, that's just a thought. I don't know. We got to look. So I got to go from 2,550 up to 5,600. So here's what I kind of do in my head. I think, like, what is that range of numbers? So if you look at this, it's about 3,000. So if I was to go by, let's say, hundreds, then I'd need 30 boxes here. If I were to go by 200s, I would need 15 boxes. I probably have 15 boxes. Let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, I definitely got 15 boxes. So I think I'm going to go by 200s. Okay, so what I did there was I first just figured out what is my range of numbers. So I subtracted these. It's about 3,000. Then if I said, all right, if I go by 200s, this tells me how many boxes I will need. So with that in mind, let me erase this stuff. Let's go by 200s. Now we're not going to start at 0 because I put that break. I think a good place to start would be 2,000. Now here's 2,200, 2,400, 2,600, 2,800, 3,000. 3,200, 3,400, 3,600, 3,800, 4,000. Notice I'm not putting in all the numbers. I don't want it to get too sloppy. 4,200, 4,400, 4,600, 4,800, 5,000. 5,200, 5,300, 5,400, 400, 5,600, 5,800. This last one here is 5,800. I'll put that in just because it's at the end. Now we're going to do the same thing for your fuel efficiency. Look at the low. The low is 12. Look at the high. It's 28. So that's a difference of 16. Okay, again, I probably could go by ones here, but I'm going to put a break. I'm not going to start at 0. Let's start at 12. 13. You could write them all in here if you want. 14. Actually, that's going to get a little sloppy. So let me just start with 12. Then I'll go 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Well, it's going to be right at the top. Okay, so perfect. That's the hardest part of this whole thing, is sort of determining what kind of scale do I want to use and how do I want to make it look. The rest is pretty easy. Now it just becomes plotting these points. So let me use green just to, I don't want to have too many colors, but I just want to sort of highlight the different things that we're doing. So the first point is this one up here, 3,200 and then 23. So I'm going to go to 3,200, which is right here. I'm going to go up to 23. There's 24, there's 23. I'm going to put a point. Let's do the next one together. 2,550 and 28. 2,200, 2,400, 2,550 is like somewhere in between those two. And then I'm going to go up to 28. It's the top one. So something like that. 4,050, which is somewhere like right by here. And then up to 19. So, okay. Now I'm going to continue this. I'm going to hit pause. When I'm finished, I'll have all my points plotted. You go ahead and do the same thing. We'll see if our graphs sort of agree when we're done. Okay, well, there you have it. I've just plotted all my points. And you can definitely see, if I was to make a prediction about this, that this is a negative correlation. In general, it appears like my data is trending sort of downward. Now, it's not perfect, never will be, it's real data, but in general, I can see it's trending downward, which means that as the weight of the car goes up, the fuel efficiency goes down. And that really makes a lot of sense. The heavier the car, probably the less fuel efficient it is. Okay, so there's our first example of making a scatter plot. Tonight for homework, you're going to have one of those to do yourself. Again, if you have any questions, don't forget, we're always on Meet each day at 10:20. Use code Whaley8. Okay, signing off.